From GBH in Boston, this is Nova Remix. I'm Caitlin Sachs. Did you know whales have legs? Well, sort of. Deeply buried within their blubbery bodies are internal remnants of hind legs and a pelvis that once supported a very different animal, one that could walk. But how could a whale walk? When was it alive? What did it look like? To answer that, we first have to go to the Valley of the Whales.
The place that we are heading toward is one of the most important places in Egypt, if not in the world, in terms of paleontology.
That's Dr. Hesham Salam, an Egyptian paleontologist.
Many people think of Egypt like ancient Egyptian civilization, like pharaohs, Sphinx, and Romans even. But what I'm studying is way beyond this time, prehistoric life.
Valley of the Whales, also called Wadi Hitan, is the world's biggest ancient whale graveyard. It's millions of years old. And here, massive skeletons with strange skulls and gigantic teeth jut out from the sandy ground of Egypt's Sahara Desert.
Here it's the middle of nowhere. It seems like an empty place, but there is tons of evidence that you can see. Fossils are everywhere, telling you what life looked like 40 million years ago.
There are so many fossils that Salam removed his shoes as he worked, careful not to accidentally crush one underfoot. He approached a rocky shelf with fossils jutting out of it.
This is typically what you see in Wadi Hitan. The bone is sticking out from the cliff, calling you to come and see it.
Even the untrained eye could see that these weren't just little shells or tiny teeth. These were large vertebrae, some over half a foot long.
And indeed, this is a really huge animal. And not only the vertebrae, but also you can find ribs all over the place. Given the size of the vertebrae, it might be getting up to 20 meters long.
That's about 65 feet long, easily longer than a school bus. The fossils there are some of the earliest whale skeletons ever found, and they may hold the key to how today's ocean giants evolved. Salam approached one of these skeletons that's been dug up and spread out across the sand.
This is one of the most complete skeleton that we find in Wadi Hitan. In the middle of nowhere, you find a lot of really huge vertebrae lying up. The skull would be over there in that rock and the ribs on both sides. This is really spectacular, huge animal that lived here in Wadi Hitan 40 million years ago. The Basilosaurus.
Looking at this skeleton laid out like this, it's easy to imagine the creature it once belonged to. Still, it fooled early scientists.
When the early scientists found this, they thought it belonged to a kind of gigantic marine reptile. And this is why they give it name Basilosaurus, which means king lizard.
But if you looked closer at the skull, it told a different story.
This is the skull upside down, and you can see all the teeth is taken up. And it's actually, they have incisors, canine, premolars, and molar, really like our teeth, which is actually a really good indication for this is not a marine reptile. This is actually mammal. So Basilosaurus, the king lizard, it's actually ancient whale.
40 million years ago, Basilosaurus was an apex predator that was the length of a bowling alley and weighed more than 7 tons. Those signature mammalian teeth contributed to a bite force of nearly 2 tons, enough to crush the bones of other whales. But of course, there was more to Basilosaurus than its bite.
Here is the arm of this beast. It actually wasn't like a regular arm for mammals, but flippers to allow it to swim in the sea.
And then further down, there was a small pelvis with 2 quote-unquote legs that were very small compared to the spinal column. Each vertebra was as thick as a paint can, and then sitting next to it was a feeble little limb about the size of a human infant's leg.
Definitely Basilosaurus cannot walk, given the size of this hind limb, comparing to the whole body, 20 meter long. Just totally cannot support walking on land. Just like T-Rex hand, do nothing.
That little limb, paired with an even smaller pelvis bone, pointed to a history of walking. Why would a marine mammal have the remnants of a pelvis if it never left the ocean? Science generally regards the ocean as a place where life started. About 400 million years ago, some prehistoric fish left the water to live on land. And over time, mammals and other land-faring creatures evolved. The reverse, a land creature evolving to live in the water, is not typical. Basilosaurus bucked the trend. It definitely could not walk and clearly lived in the water. But it had the remnants of limbs, which means somewhere in the past, one of its ancestors was a walking creature that adapted to live in water. So, what was that early marine mammal like? Paleontologist Dr. Philip Gingrich stumbled upon an answer while he was trying to research horses.
I grew up in the Midwest, and I wasn't near the ocean, and I didn't know anything about whales. I knew so little that I wasn't interested.
In 1978, Gingrich went to Pakistan to search for prehistoric horses. Instead, his team found the remains of a mysterious creature.
The first thing we found was this skull, back of a skull. It's not complete. The front, the heart with the eyes and the teeth and everything is broken off. When I first saw it, I had no idea what it was. I was probably disappointed because I was looking for horses, and it clearly wasn't a horse, but what it was, I couldn't figure out.
This was Pakicetus. It was about 50 million years old, 10 million years older than the monstrous Basilosaurus. But was it a whale? Did it make its life in the water? When Gingrich took a look, he found the answer in Pakicetus's ear.
So when you look at this covering bone, covering the ear, it's very dense, it's thickened, it has a sloping surface on this side, and in modern mammals, those are only found in whales. And why? To enable them to hear in water. This bone was the key to understanding that Pakicetus is a whale.
It was groundbreaking. And as they discovered more Pakicetus fossils, they realized something else. This whale could walk.
Pakicetus is an animal a little bigger than a wolf, probably built approximately like a wolf. It has teeth like a carnivorous mammal.
Not exactly what you picture when you think of a whale. Its eyes were spaced closely together near the top of its head, which allowed it to see above the surface while swimming. And at the end of its toes, it had tiny hooves. And it had a long snout full of sharp teeth to probe the riverbed for prey.
Why was Pakicetus spending so much time in the water? I think it was because the water was full of fish. And judging from its teeth, it's pretty clear that they were taking advantage of that, going in the water, feeding on the fish, and didn't have much competition. And of course, it didn't take long until they moved into the water more permanently.
Pakicetus may have been more wolf than whale, but it was the start of an amazing evolutionary journey back to water.
The oldest fossil whale anybody ever found. It changed the course of my entire career because I got interested in this as an example of evolution. It's especially interesting because it seems like it's backwards. It's back to the sea, not out of the sea.
Which begs the question, what happened as Pakicetus started to evolve? What happened when the wolf became more whale? Nova and Nova Remix are supported by Carlisle Companies, a manufacturer of innovative building envelope systems. With buildings responsible for over a third of total energy use and energy demand on the rise, Carlisle's mission is to meet the challenge head-on. Carlisle's advanced, energy-efficient, and labor-saving solutions can help reduce strain on the grid. Operating nearly 100 manufacturing facilities across North America, Carlisle is dedicated to helping the transition to a smarter, more sustainable future. Learn more at carlisle.com. Nova and Nova Remix are sponsored by Viking Cruises. Ocean voyages, expeditions, river journeys, Viking is dedicated to bringing travelers closer to the destination, offering a small ship experience and a shore excursion in every port. Learn more at viking.com. Let's go back to Hisham Salam and his fellow paleontologist Abdullah Gohar as they look at a new piece of the puzzle in their lab.
This is one of the most important discovery. Here we have nearly complete skull, a lower jaw, some of the vertebrae and some of the broken ribs.
Salam and his team discovered a previously unknown species of ancient whale, dating back to 43 million years ago, about 7 million years after Pakicetus. Gahar named it Phiomacetus anubis, after Anubis, the ancient Egyptian god of death.
We have a clear indication of very powerful predator that hunt everything, so we clearly can consider him the god of death for all living animal that lived 43 million years ago.
It was one of the oldest whale fossils ever unearthed in Africa. But could it walk on land like its ancestor Pakicetus? The team hadn't found leg bones, but a bony projection in the vertebra was a clue.
This is the thoracic vertebra from the rib cage region, and you can see this is sticking out. Point here is called neural spine, but this is very clear evidence of walking lifestyle because the longer this sticking out, the more ability to hold massive muscles that support the walking on four legs.
Bone structure and size can indicate musculature. Bigger muscles mean bigger bone mass. For instance, think about the biggest bone in our body, the femur, which holds our thighs, one of the most powerful muscle groups in the body. Paleontologists only have bones to work with, but they can infer the muscle structure based on the size of the bones. Salam and Gohar were making a similar inference by looking at the pointy bit at the end of each vertebra, the part that you might feel if you touch your back. By looking at that, they could see that the musculature of Anubis would have been similar to land mammals that walk on four legs today, like a large cow whose vertebrae stick out up to 3 inches in the mid-back.
But if you look at the modern dolphin, you can see clearly this sticking neural spine is much, much shorter comparing to the walking terrestrial animal.
By comparing Anubis's vertebrae to the vertebrae of both modern dolphins and walking mammals, the team figured that since Anubis had strong back muscles, it probably used them for walking. Anubis was a formidable marine predator. It measured around 10 feet long and weighed over half a ton. It spent extended periods in the sea where it hunted fish and turtles. But from the bones the team has found, they think it was able to come back to land. And it didn't wriggle out of the water like a seal. Anubis was probably a walking whale. To find out more about Anubis's place in the whale family tree, Salam and Gohar took the skull to a nearby hospital for a CT scan.
The nasal opening would be right here, 1/3 the way back in the snout. Comparing to the modern whale, the blue hole would be on the top of the skull.
Land mammals' nostrils are at the tip of the nose. Modern whales' nostrils are moved to the top of their heads to become blowholes. But Anubis's nostrils were 1/3 of the way back on its snout. It was one step closer to becoming fully aquatic. And just as we can examine prehistoric remains to find insights on the whale's journey back to water, examining modern marine mammals also helps complete the picture.
Okay, let's unwrap.
Here, comparative anatomist Dr. Joy Reidenberg is studying the body of a young beaked whale that was found dead along the U.S. coastline. Joining her is evolutionary biologist Dr. Michael McGowan.
It's always really sad when you have a stranded whale.
Yeah.
But for us, this is a gold mine. We have an opportunity here to learn something about an animal that's quite rare.
These particular species are rarely sighted at the surface because they just come up, take a quick breath, and go back down.
What's really cool, I think, is beaked whales are really adapted to stay at depth. That's their norm.
Cutting into the animal's abdomen, they revealed something curious, an important clue about the origins of whales.
Look how weird this is. These animals are carnivores. You expect them to be like a cat or a dog and have one stomach chamber. But in fact, they don't. They have multiple stomach chambers, kind of like hoofed animals, like cattle or deer or sheep. So you got 1, 2, 3, 4, 5, 6, 7, 8. I think there's 8 or 9 chambers, which is crazy when you think about it.
It's crazy, it's nuts.
That's right. Whales have stomachs with multiple chambers. And what other mammals have multiple chambers like that? Animals like camels, deer, and cows.
Just like cows have multiple stomachs to digest their plant matter, whales have multiple stomachs to digest what they're eating, which is completely different. Fishes and squid, but it's still coming from the same structure as a terrestrial mammal.
It's just a throwback to their terrestrial ancestry of having a multi-chambered stomach because their ancestor did.
As Reidenberg and McGowan looked over the whale's anatomy, they made another key observation, this time about the way it swims.
And that's another remnant of its mammal past, is that they move their spine up and down. And with fish and even reptiles, they move side to side.
You watch a snake move, you watch a crocodile walking, they're swimming like fish, but on the land with legs. When you get to mammals, the legs come underneath, the spine and the body come off the ground, and now they're free to gallop. And when whales went back into the water, they kept the up and down spinal movement, so they're still galloping in the water.
Even with all the anatomical evidence across modern and prehistoric specimens, it was still hard to believe that whales could ever walk. But McGowan explained how this might work at the genetic level.
When we look at the genome of whales, we see that whales still have a lot of the genes from when they used to live on land. So they still have genes involved in smelling, sweat glands, color vision, producing saliva. But these genes are inactivated and they gradually degrade. But I think this is incredibly powerful evidence that shows that whales come from land ancestors, that they still have these genes in their genomes, even though they're inactivated.
If we trace back through a whale's DNA, we could find a modern comparison to what whales would be if they had stuck with walking. Scientists compared whale DNA to a wide range of other animals to figure this out.
So if you think about different marine mammals, such as a manatee or a seal sea lion, they all swim and live in the ocean and have similar adaptations to whales and dolphins. But we can look at the DNA to see whether whales and dolphins are closely related to those other groups, or whether they're related to another species entirely. They came up with a really surprising finding, and the finding was that the whale's closest relative, using DNA, was the hippo.
Whales and hippos both descended from a common hooved ancestor that lived about 5 million years before Pakicetus. With eyes set back atop the skull and a wide mouth, the family resemblance was striking.
Some of the earliest whales, like Pakicetus, may have lived like hippos. Also, hippos give birth underwater, they nurse underwater. Their skin is also very thick. So it's interesting to think that maybe the common ancestor of whales and dolphins had these particular features.
Hippos may be modern walking whales, but the story of the whales' ancestors and their long journey from land back to water is far from complete.
Has the mystery of whale evolution been solved? To some degree, but when we fill a gap, we make two more, and so we're always going to want to know more.
There's more to find in Wadi Hitan. There are so many fossils still hidden inside the rocks, and we're hoping someday to find very primitive whale and very ancient deposits that can actually complete the story in whale evolution. That would be a really huge discovery.
What more will we learn about the lives of ancient whales? And what hidden adaptations do their descendants carry in their DNA? Only time will tell. 50 million years, to be exact. This has been an episode of Nova Remix. Subscribe for more episodes and drop us a comment with your thoughts or questions wherever you get your podcasts. And if you want to see what these ancient whales looked like, check out the documentary When Whales Could Walk on Nova's website, YouTube channel, and the PBS app. Nova Remix is a series from GBH and Nova, and it's distributed by PRX. Executive producers are Julia Court and Chris Schmidt, and Senior Director of Digital Media is Nadia Petchek-Rawls. Devin Maverick Robbins is Managing Producer of Podcasts for GBH. This episode was produced by Chris Neighbors with sound design by David Porter. I'm Caitlin Sachs.